To know the outliers in your data set, the first thing that you can do is just draw the box plot of that variable. The box plot will reveal the outliers as dots that are present outside the whiskers. So in this one, in case of teachers column, you have a number of outliers over here. Now to get the actual values of the outliers themselves, you can use the boxplot.stats. In boxplot.stats, the out column, the out variable contains the values of the outliers. Now what makes them outliers? The reason is any point that is lying outside the whiskers, both the top as well as the bottom whiskers, any point that lie outside them are considered as outliers. And what defines this whisker? It is nothing but 1.5 times the interquartile range. Interquartile range is the distance between the top line on the box and the bottom line on the box. 1.5 times this distance is where this whisker lies. Now, how to get the range, the actual exact range where the top and the bottom whisker lie? That you can get from the stats variable in the output of boxplot.stats. The first item is the lower whisker and the last item is the upper whisker. Likewise, you can plot and visualize the outliers in total enrollment, cal w percentage. So it's time for a mini challenge. The challenge for this lesson is from CA school dataset. You can load the dataset using this function. From this dataset, find the outliers in AVG INC, average income column from CA school dataset. Also print out the cutoff values for the outliers, that is the lower and the upper whiskers. Try it out in your R console if you have access. Otherwise, let me show you the answers. So here's the solution. I have already imported df, so no need to worry. Boxplot.stats will give me the values of the outliers itself. Getting the first and the fifth position of $stats object will give you the cutoffs for the outliers. And to extract the actual outlier values, it is present in $out. Now that we have found the outliers in each of the columns, a method to handle these outliers is just to replace these outliers with a more meaningful value. It could be the 95th percentile or 99th percentile, or it could be the 1.5 times the IQR, the cutoffs that we have in the $stats variable itself. So if it is on the higher side, you would replace it with the higher cutoff. If it is on the lower side, you can replace it with the lower cutoff. Replace all the outliers in the lower end with lower cutoff. So that is one approach. Another approach could be you can simply replace all the outliers that are shown here with missing values and let the predictive modeling approach such as mice to replace or fill those missing values. That is also another approach. However, the first approach is more commonly followed and widely used in data science projects. Before we close, I want to point out that the approach that we have just seen, that is based on box plot, is based on just one variable at a time. To determine outlier, we are looking at one variable only. But a more efficient approach to find out outliers, or rather I would call them as influential points, is a technique that is based on Cook's distance that we will see later in the course.